We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside.
On July 23, 2024, Europe's Solar Orbiter spacecraft observed a super-powerful solar flare erupting from the far side of the Sun. This flare wasn't the most extreme ever recorded, but still, we got extremely lucky this time not to get fried by it. Such solar flares often cause long-lived, raging radiation storms, and if such a storm moves in the direction of Earth, it can lead to worldwide blackouts. Before we go deeper into details of that potentially disastrous solar flare, we need to figure out what exactly this solar phenomenon is. Solar flares occur because the magnetic fields in the atmosphere of our star are moving non-stop. When the Sun is approaching its solar maxima, and that's the most active period of its 11-year-long cycle, which is, by the way, exactly what's happening now, its magnetic fields get more and more tangled, making our star look like an enormous ball of tangled rubber bands. They loop around, cross over one another, cut one another off, and then reconnect. Ever seen iron filings sprinkled on a bar magnet? These filings line up along the magnetic lines of force. Like that, the hot plasma on the surface of the Sun is at the mercy of the magnetic lines of force. Sometimes, when the magnetic fields interact with each other, some plasma gets disconnected from the fields, and its particles accelerate to immense speeds and send powerful radiation to space. That's what a solar flare is. Other times, our star throws off massive amounts of matter. Those events are coronal mass ejections, CMEs. Just one CME can contain as much as 20 billion tons of material. If that material were rock, it would create a mountain about 2.75 miles across and almost a half a mile tall. The ejected material often travels at a speed of over 1,000,000 miles per hour. Solar flares and CMEs are the most powerful explosions in the solar system, releasing unimaginable amounts of energy. Solar flares have their own classification according to their strength. The smallest and weakened ones are A and B class. Then there are C and M class solar flares, and the strongest are X class flares. A number from 1 to 9, and in some cases a larger one, accompanies each letter. That's similar to the Richter scale for earthquakes. A and B class flares are too weak to affect our planet. As for C class flares, they may have small, noticeable consequences. M class flares can cause short radio blackouts at the poles and weak radiation storms that can still harm astronauts. But the most dangerous of them all are X class flares. These are flares more than 10 times more powerful than X1. That's why the classification of X class flares can go higher than 9. Now let's get back to that recent solar flare. It was X14 class 1. Now, we already know that it means it was an extra strong flare. Other large flares astronomers have detected recently include an X12 solar flare that happened on the 20th of May and an X10 flare that occurred on the 17th of July. All of them have come from the backside of the Sun. If we talk of the Earth side of our star, the largest solar flare that has been recorded so far within this solar cycle happened on the 14th of May. It was an X8.7 flare that led to radio blackouts, and a strong geomagnetic storm leading to magnificent auroras all over the world occurred a few days earlier. Powerful coronal mass ejections accompanied this storm. As for the July X-class flare, it was so powerful that it could have ended up tragically for us. Luckily, all that magnetically charged plasma blast that accompanied the flare didn't travel in our direction. If it had, it would have been quite the solar storm. Auroras would have been incredibly impressive and a wee bit terrifying in their magnificence. But at the same time, such a dynamic blast of energetic particles hurtling our way could have caused major technological problems and electrical blackouts, like the event in 1989, which severely harmed Quebec's power grid, or a much earlier catastrophe that still managed to cause a lot of harm to the world. I'm talking about the Carrington event, which occurred in 1859 and was the first documented solar flare affecting our planet. It happened on the 1st of September and was named after Richard Carrington, the solar astronomer who witnessed the flare through his own telescope and sketched the sun's sunspots. According to scientists, that flare was the most powerful documented solar storm over the last 500 years. The Carrington event triggered auroras that were visible as far south as the Caribbean. It led to severe interruptions in telegraph services all over the world, even shocking some telegraph operators and sparking fires after discharges from the lines ignited telegraph paper. Another major solar flare that erupted on the 4th of August, 1972, destroyed long-distance phone communication across a few states, including Illinois. This event even made the American Telephone and Telegraph Company redesign its power system for transatlantic cables. Now let's move to March 1985, when two super-powerful CMEs triggered a geomagnetic storm, which, in turn, set off a power blackout in Canada on the 13th of March. This blackout left around 6 million people without electricity for 9 hours. It is said that the flare disrupted electric power transmission from the Hydro-Quebec generation station and melted a few power transformers in New Jersey. And still, this solar flare was nowhere near the power of the Carrington event. The Bastille Day solar storm took its name from the French national holiday because it occurred on the same day, on the 14th of July in the year 2000. It was an X5 class event that caused some satellites to short-circuit and resulted in radio blackouts. It's still one of the most highly observed solar storm events. From October to November 2003, our star unleashed a series of large solar flares and coronal mass ejections, and they did reach Earth and slam into our atmosphere. Those solar storms, also known as Halloween storms of 2003, caused aircraft to be rerouted, impacted satellite systems, and led to power outages in Sweden. Besides, the Solar and Heliospheric Observatory couldn't fulfill its functions during this solar onslaught. On the 28th of October 2003, the Sun sent a whopper of a solar flare our way. The fire was so powerful it overwhelmed the spacecraft sensor that was measuring it. The sensor topped out at a whopping X28. But later, scientists figure out that the flare had reached a peak strength of about X45. One more thing that made the Halloween storms so scary was that they happened during a time in the solar cycle when solar activity is usually quiet. That's 2 to 3 years after the solar maximum. According to NASA's statistics, just 17 powerful flares erupted from our star during that time. The Sun spewed out another X-class solar flare on the 5th of December 2006. It was an X9-class flare that disrupted satellite-to-ground communications and GPS navigational signals for around 10 minutes. That solar storm was so powerful it even damaged the Solar X-ray Imager instrument on the GOES 13 satellite. It sustained damage to several pixels of its detector. In February 2022, SpaceX experienced the terrifying power of our star when a devastating geomagnetic storm destroyed 38 Starlink satellites worth tens of millions of dollars. It happened shortly after they were deployed. Unfortunately, Starlink satellites are especially vulnerable to geomagnetic storms since they're released into extremely low-altitude orbits, between 60 and 120 miles. They also rely on their onboard engines to overcome the drag force and raise themselves to their final altitude of around 350 miles over the surface of our planet. The thing is, during a geomagnetic storm, Earth's atmosphere absorbs energy from the storm, heats up, and extends upwards. It results in a denser thermosphere, which means more drag, and it can be a serious issue for satellites. That's exactly what happened. The batch of newly released Starlink satellites didn't manage to overcome the increased drag and started to fall back, eventually burning up in the atmosphere. Hey, listen up. There's a red alert. NASA supercomputers have calculated that there are only 2,021 years left until the end of the Earth. Our planet is about to… Oh, wait a minute. Oops, I'm sorry. I thought these zeros were a mistake. Well, the research actually says 1,000,000,2021 years in the future. Woo! That's a relief. Breathe normally. Still, this means that our planet officially has an expiration date. And no, this is not science fiction. It's a very real study that shows how, why, and when life on Earth will end. So, thanks to NASA and Japan's Toho University, we can now mark the calendar. It'll happen in around 1 billion years. But what about how and why? Well, even as recently as the early 20th century, scientists still didn't know what powered the Sun. One of the first big ideas was that the Sun was basically a giant piece of charcoal, just a huge ball of fire burning some kind of fuel. But that was easy to rule out. At the rate the Sun puts out energy, it would have burned through that kind of fuel in just a few thousand years. And even back then, geologists and paleontologists already agreed that Earth was at least 100 million years old, if not more. That meant the chemical burning couldn't have possibly kept the Sun shining for that long. So, scientists turned to another, more nerdy theory – gravitational contraction. This idea was that the Sun shines because of its own weight. Its gravity pulls all the gas inward, squeezing itself tighter and tighter. It's kind of like warming your hands by rubbing them together. We know that gas giants like Jupiter and Saturn are slightly contracting under their own weight and giving off more heat than they get from the sun. So yeah, gravitational contraction, also known as the Kelvin-Helmholtz mechanism, is very much real, but it's not what powers the sun. When researchers did the math, it showed the sun could only shine like that for about 20 to 30 million years. Eventually, scientists learned that the real secret behind the sun's power and longevity was something way more powerful – nuclear fusion. Now, deep inside the sun, it's unbelievably hot. We're talking 27 million degrees Fahrenheit, and it's under crazy pressure because the sun is so big and heavy. All that heat and pressure squashes hydrogen atoms and forces them to stick together. When 4 hydrogen atoms get squished hard enough, they turn into something new, a helium atom. When that happens, a little bit of their mass turns into energy, and that's what becomes sunlight and heat. For centuries, people feared the sun would someday go cold, and that will happen, eventually. About 5 billion years from now, our star will run out of hydrogen, and gravity will take over. But long before that, Earth will already be toast. According to a NASA life extinction prediction, our planet will become a scorched, uninhabitable rock, not because the sun will go out, but because it will burn too hot. It turns out that those old apocalyptic ideas were not completely off. The sun will destroy life on Earth, just not by going cold. But why? Well, it's because, with time, the sun is getting brighter. And I'm not talking about its mood. It releases more energy. It's a slow, natural side effect of the nuclear fusion we just mentioned. Deep in the core, the sun has been fusing hydrogen into helium for billions of years. But as more helium piles up, the core gets denser and hotter. Think of it like a pressure cooker. The more pressure builds up inside, the more heat rises from within. That extra heat speeds up fusion, which means more energy gets released, and the sun starts shining just a little bit brighter. It's not dramatic, we won't notice it in a lifetime, but the future-proof androids we're going to build just might. With time, the extra heat adds up. The sun is already about 30% brighter than when the Earth was born. But life decline is going to happen much earlier, even before the given deadline. As the sun keeps cranking up the heat, Earth is gonna sweat. The extra sunlight raises global temperatures to the point where the ocean surfaces hit around 117 degrees Fahrenheit. That's hot enough to mess with the planet's entire climate system. Water vapor begins to rise from the oceans and accumulate in the upper atmosphere. This causes even more heat to be trapped, creating a thick, humid layer around Earth. Scientists refer to this ongoing cycle as the moist greenhouse effect. The rising temperatures aren't just drying out our planet, they're also harming plants. Plants rely on carbon dioxide from the air to grow and thrive. However, as Earth warms up, certain natural processes can take too much carbon dioxide out of the atmosphere. When that happens, there won't be enough CO2 left for plants to survive. Forests will disappear first, then grasslands, bushes, and even the toughest plants that usually handle extreme heat. This all will lead to oxygen collapse, because plants and CO2 are crucial for photosynthesis. In simple terms, this is how plants use sunlight, along with water and carbon dioxide, to create their own energy and produce oxygen as a waste product. Right now, oxygen makes up about 21% of Earth's atmosphere. But once it drops below even 1%, complex life as we know it will most likely disappear. Earth's biosphere will shrink to just a few microbes and extremophiles, hiding deep underground. But even they won't last long. It's worth noting that scientists ran 2 versions of the simulation, one with life like we have today and one with none at all. Surprisingly, both worlds lost their oxygen at about the same time, around 1 billion years from now. That means plant life and photosynthesis do help, but they're not the main thing keeping oxygen in the atmosphere. It's actually a long-term chemical battle between volcanic gases and rocks that gradually soak up oxygen like a sponge. And even after most life is gone, the heat will keep going, causing oceans to boil. Not all at once, but slowly and steadily, the oceans will begin to evaporate into the atmosphere. But that vapor won't just come back down as rain like it does now. Why? The atmosphere will be too hot and thick for that. Instead, sunlight will start breaking the water apart, and hydrogen will escape into space permanently. Once it's gone for good. Basically, instead of raining back down, Earth's water will slowly leak into space until there's nothing left. Even before the last puddles vanish, life under the sea will be long gone. Once the balance of temperature and oxygen is lost, not even the hardiest ocean life can hold on. In the end, Earth will become something we can barely recognize, a dry, lifeless rock. There will be no water, no oxygen, and no life left. The oceans will be gone. The atmosphere will be thin and toxic. Even the most resilient microbes will have disappeared. However, the sun will still shine in the sky. Earth will keep orbiting just like always. It'll still be a planet, just without life. But long before that cosmic finale, Earth will already be uninhabitable, which raises the big question. So, what could future humans do about all this? Well, escaping sun radiation and extinction might end up being humanity's biggest engineering challenge yet. Maybe we'll build massive space colonies and leap from planet to planet, staying just ahead of the sun's deadly heat. Even if we terraform Mars, making it more Earth-like so we can inhabit it, it'll still be cooking in the same solar oven, just on a lower shelf. Or maybe we'll live in giant rotating space habitats, like O'Neill cylinders, floating mini-worlds with gravity and recycled air, water, and energy to support long-term survival. Those could drift farther and farther from the sun as things heat up. Or who knows, maybe we'll upload our minds to the cosmic cloud or hop into a higher dimension and watch the universe like it's, Netflix. Okay, this is definitely too nerdy, and we're going deep into sci-fi territory. But whatever the solution may be, humankind has a long time ahead to figure out how to survive the eventual end of Earth and life, or maybe even preserve it in whatever form it takes. Tick-tock. No, not the app, a clock. You see, scientists already know the exact doomsday date. Tick-tock. The countdown has started. We only have 250, no, not years, millions of years left on this beautiful planet we call Earth. Well, let me apologize first. I might have scared you with all these end-of-the-world things. You and I certainly won't live to witness it, but we already know when it will all go downhill, and most importantly, why. This 250 million years deadline is not precise. If we change our ways, humans can stick around for more or less, depending on what way we choose. Researchers ran some computer simulations and found that Earth might be left without any mammals if temperatures kept climbing to between 104 and 158 degrees Fahrenheit. What's the culprit? Well, it's mainly our love for fossil fuels and the greenhouse gases we keep pumping into the atmosphere. It's easy to think that mass extinctions are a thing of the past, especially since the last big one wiped out dinosaurs 66 million years ago. But surprise, we're actually overdue for another one, and this time, it's all on us. Throughout Earth's history, there have been 5 mass extinctions, and it's been 66 million years since the last one. But this upcoming one is special. It's totally human-made. As Earth's tectonic plates shift over millions of years, they eventually come together to form supercontinents. This could lead to some pretty serious natural disasters, and, well, it might as well mean the end. Having one continent instead of 7 is already pretty extreme, as it will totally make us rethink the way we live. Now, scientists said that a new supercontinent would create a trio of problems. The continentality effect. No, I didn't make that word up. A hotter sun and rising CO2 levels, resulting in a super hot planet. This would lead to tough living conditions for mammals with limited food and water. If temperatures hit 104 to 122 degrees Fahrenheit, and maybe even more extreme fluctuations, humans and lots of other species would struggle to cope since we can't shed heat effectively through sweating. Some experts believe the future looks pretty grim. CO2 levels could end up being double what they are now, and the sun's radiation could increase by about 2.5%. With the supercontinent likely to be in hot, humid tropics, much of the planet could be facing extreme heat. Finally, in about 250 million years, Earth is expected to morph into a donut shape with a big inland sea in the middle, leaving the Pacific Ocean to cover most of the surface. Honestly, no matter how well scientists crunch the numbers, they can't see the future, especially when it's this far out. But hey, those who ignore history are doomed to repeat it. So let's jump into the history of the 5 massive extinctions that have already happened. The late Ordovician mass extinction hit around 445 million years ago and was a huge deal for ocean life, wiping out up to 60% of marine species, including 85% of all marine creatures. Unlike other extinctions, it really didn't change ecosystems much. It had 2 main phases. First, the climate cooled due to glaciation, causing sea levels to drop and many marine animals to lose their homes, leading to new cold water ecosystems. Then, when the ice melted, warming returned, but oxygen levels plummeted, creating toxic ocean spots. I know, it all sounds horrible, but let's see the results. The planet is still habitable, marine life is booming, and, by the way, there are even species, some hard-bodied arthropods like horseshoe crabs, that are still around. So from our perspective, it feels like it wasn't a disaster so much as a step for further development of our planet. But let's not make premature conclusions and take a look at the next mass extinction. The late Devonian extinction was a big deal in Earth's history, happening about 272 million years ago. The main event during this time was called the Kellwasser event, which wiped out about 19% of all family groups and half of all types of living things in the oceans. Another extinction, the Hangenberg event, occurred around 359 million years ago and marked the end of the Devonian period. This extinction wasn't just one event, but might have happened over a long time, possibly from 500,000 to 25 million years. Some scientists think that there were as many as 7 separate extinction events during this period. By the late Devonian, plants and insects were starting to thrive on land, and oceans were filled with huge coral reefs. The continents were also moving together to form what we know as Pangaea. Most of the creatures that disappeared were in the oceans, like brachiopods and trilobites, especially the ones that built reefs. The reasons for this extinction are still a mystery. Some ideas include changes in sea levels, lack of oxygen in the ocean, global cooling, or even volcanic activity. There's also a theory that a comet hit Earth. Interestingly, it seems that the loss of diversity came more from fewer new species forming rather than a spike of species dying out. During this extinction, oceans became low in oxygen, which helped preserve some organic material. This, along with the porous rocks from that time, made Devonian rocks a valuable source of oil, especially in places like Canada and the US, way before they became Canada and the US. So far, these terrible mass extinction events don't sound that bad. Now, about 250 million years ago, there was a huge event called the Permian-Triassic extinction, often called the Great Dying. It was probably the worst extinction event ever on Earth. During this time, a whopping 59% of all biological families and 83% of different kinds of living things disappeared. This included 81% of marine life and 70% of land animals. Even insects were hit hard. Scientists believe the main cause of this mass extinction was massive volcanic eruptions in what we now call the Siberian Traps. These eruptions released a ton of gases, like sulfur dioxide and carbon dioxide, which messed up the oceans and made it hard for many creatures to survive. The atmosphere's carbon dioxide levels skyrocketed from about 400 parts per million to 2,500 parts per million. Other possible reasons for this extinction include burning oil and coal during these eruptions, intense weather patterns like El Niño, and even a possible asteroid strike. All of these factors combined, creating a really tough environment for life on Earth at that time. Okay, this one seems serious. Let's proceed though, shall we? The Triassic-Jurassic extinction event, happening around 200 million years ago, was a major wipeout of many species, both on land and in the ocean. In the oceans, between 23 to 34% of marine life vanished. On land, most reptiles, except for crocodiles, dinosaurs, and pterosaurs, those flying reptiles, went extinct. Some of the reptiles that went extinct were once very common. Luckily, plants, early mammals, and the groups that survived, like dinosaurs and pterosaurs, thrived and became the main animals for the next 135 million years. Scientists think this extinction might have been caused by huge volcanic eruptions, which released lots of carbon dioxide into the air. This led to global warming and made the oceans more acidic. The Cretaceous Paleogene extinction event happened around 600. Something enormous is hiding right below Hawaii, deeper than any drill could ever reach. This strange underground bubble, almost 1,800 miles down, tells us impressive new details about the formation of the islands and could cause an eruption that will affect thousands of lives. Scientists call strange formations like this blob ultra-low velocity zones. When earthquakes happen, they send vibrations through the planet, and they move fast through most rocks, but they slow way down when they pass through certain deep layers. That slowdown tells geologists something unusual sits there. The giant blob beneath Hawaii belongs to the biggest category of these structures, a mega ultra-low velocity zone, a massive chunk of material sitting right on the border between Earth's mantle and its core. To find out what this monster actually looks like, scientists track two different types of earthquake waves. The first type, pressure waves, compresses rock like squeezing a spring. Another type, shear waves, moves rock up and down like shaking a rope. When they combined both signals, researchers built a much clearer picture of what lies deep below Hawaii. Scientists used to think that this blob was soft and partially melted, like thick lava slowly rising toward the surface. But this new seismic data showed that the blob isn't gooey at all. It's mostly solid rock, dense, heavy, and packed with iron. This discovery helps explain a real mystery that puzzled scientists for decades. Most volcanoes form along the edges of tectonic plates, but Hawaii doesn't sit anywhere near one of those boundaries. It floats right in the middle of the Pacific Plate. Yet the islands somehow form from some of the most active volcanoes on the planet. They used to explain this with a hot spot, a column of heat rising from deep inside the Earth like a blowtorch slowly melting its way upward. But now, it turns out that the giant iron-rich blob anchors that heat plume in place, like the base of a lava lamp that keeps the flow steady for millions of years. The material the structure is made of could even be leftovers from a basal magma ocean, a gigantic layer of molten rock that may have existed deep inside Earth when the planet first formed. When that ancient ocean cooled and crystallized, heavy elements like iron sank downward and created dense pockets, and the blob under Hawaii might be one of those survivors. Now, structures like this don't just sit quietly forever. Heat constantly flows through Earth's mantle, and when those flows shift, they can tug on deep structures, redirect heat, and sometimes destabilize them. If the system beneath Hawaii ever changes in a major way, it could intensify the volcanic activity above. We already see hints of that restless energy. Hawaii has thousands of earthquakes every year. Most of them are tiny, so small that only sensitive instruments detect them. On average, Hawaii has about 100 magnitude 3 earthquakes per year. Those are strong enough for people to feel. Roughly 10 quakes reach magnitude 4 annually, and about 1 magnitude 5 quake shakes the islands every year. Bigger events happen less often, but they still happen. Most of this activity is going on around the Big Island, which has several volcanoes. In early March 2026, Kilauea launched fountains of lava nearly 1,300 feet into the air. Bright red streams of molten rock blasted upward, and ash and volcanic fragments rained down across nearby areas. Authorities temporarily closed parts of Hawaii Volcanoes National Park and sections of Highway 11 because falling debris created dangerous conditions. The eruption didn't threaten homes directly, but it still caused real problems. Ash drifted across nearby communities, and tiny rock fragments coated roads and rooftops. All that activity connects to the same deep engine, the hotspot anchored by that enormous iron-rich blob nearly 1,800 miles beneath the islands. Now, let's travel north, where something pretty scary lurks beneath the western edge of North America. Something capable of reshaping the entire coastline. Scientists think that 2 giant earthquake faults, the Cascadia Subduction Zone and the San Andreas Fault, don't just exist side by side, but may actually affect each other and act like giant dominoes. Cascadia stretches along the Pacific Northwest, and the San Andreas cuts through California. Scientists found evidence for this possible impact on the ocean floor. They pulled long cylinders of mud and sediment, and these cores are like geological history books that preserve layers of debris from ancient earthquakes. Inside those layers, researchers saw that pairs of earthquake deposits sit almost on top of each other. Geologists call them doublets. 2 massive quakes struck so close together in time that the ocean barely had time to settle between them. And that discovery points straight to one of the most chaotic tectonic zones on the planet, the Mendocino Triple Junction. This is where 3 tectonic plates collide and grind together, like crooked gears inside a machine. It's also the exact place where the San Andreas Fault meets the Cascadia Subduction Zone. Now, when one fault ruptures, it sends shockwaves of stress through the crust. That stress can destabilize the neighboring fault and push it toward breaking too. A Cascadia megaquake alone could reach magnitude 9 or higher. That kind of earthquake could tear open 600 to 700 miles of seafloor and send a massive tsunami racing toward the Pacific coast. And if Cascadia ruptures first, the shifting stress might trigger the San Andreas shortly afterward. In the worst-case scenario, people in California could feel one enormous quake, watch buildings sway and highways break apart, and then see a second disaster just minutes later. And the opposite sequence could happen too. The San Andreas could snap first, redistribute pressure through the crust, and nudge Cascadia to failure. In this case, people living in the affected area might survive the first quake and then see the ocean suddenly pull away from the shoreline. And that's the chilling signal that a tsunami could arrive in about 20 minutes. Scientists know from analyzing the sediment that this sequence has happened before. There were at least 10 paired earthquakes over the past 3,100 years. The scariest part is that a new massive earthquake isn't about if, it's strictly about when. Now let's jump across the Atlantic to southern Italy. Just west of Naples, there's a massive volcanic system called the Campi Flegrei caldera. It means something like burning fields, and it earned that title honestly. About 109,000 years ago, a huge eruption blasted ash and rock across the region. It removed more than 36 cubic miles of magma from beneath the surface. It's a volume close to the massive eruption that formed the Campi Flegrei caldera around 40,000 years ago. That earlier eruption carved a crater about 9 miles wide and spread volcanic ash across huge parts of Europe. Today, more than 400,000 people live directly inside that ancient crater. The soil there feels incredibly fertile because crops have grown on broken-down volcanic ash for centuries. But the same geology that makes the land productive also hides enormous energy underground. Researchers recently studied ancient rock layers preserved in mountains and deep boreholes around the region. That's how they found out that Campi Flegrei may produce giant eruptions more often than scientists previously believed. That doesn't mean a catastrophic eruption will happen anytime soon, but it does change how researchers see the long-term danger. When these eruptions occur, they don't behave as ordinary lava flows. They generate pyroclastic flows, and those are fast-moving avalanches of hot gas, ash, and rock that race across the ground at highway speeds. Some ancient deposits from that eruption, more than 100,000 years ago, reach more than 6 feet thick in certain places, which proves just how violent the bang was. When you connect all these discoveries together, you once again see that our planet doesn't just sit quietly beneath our feet. It moves, breathes, and occasionally reminds us who really runs the place. And most of the time, the biggest forces shaping our world hide thousands of miles below where we stand. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nga and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific, and 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. but there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plate thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? All right, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon. Summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, This period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a super volcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. the monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail: communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.